All right. All right, that means a lot. Right. I'm not doing it. I'm not wasting my time, right?
You shall go back to it, sir.
Yeah.
Yeah, I understand.
All right. So that's good. That's good. All right. So I will continue. All right. So yeah, we said that the specific heat capacity is the amount of heat energy that is required to raise 1 kilogram by Kelvin by 1 Kelvin. Raise the temperature of 1 kilogram by 1 Kelvin or 1 degree Celsius. And remember that 1 kilogram is the same size of 1 Kelvin, right? Don't get these two mixed up. This can happen to any one of us, right? So but we should really try and pay attention to that. All right, so let's look on our units here. All right, let's go back to the first one. Now, we said that our formula is C equal heat energy. C is our heat capacity, right? Over the temperature rise. There's another mistake again. I'm sorry I did this in a rush, right? Busy weekend. All right. Yeah, so it's the big C is for heat capacity, while the small c is for specific heat capacity. Are we all seeing that? Uh,
Yes, sir.
all right.
Yes, sir.
No. If you look on our units, we have what is this right here? What for which quantity is this attached to?
Joule per
Kilograms.
kilogram.
What's that
Yes,
for?
Energy.
Kilograms is for what again?
Energy,
mass.
sir.
Isn't it mass?
Mass. Right. So kilogram is for mass, right?
Yes, sir. And J is for energy.
Right. So J, our J here is for energy, and our K here is for what again?
Kelvin. Kelvin, sir.
Yeah, but it's Kelvin. But for
Gram.
what?
Temperature.
Kilogram.
Temperature, right?
Oh.
Yeah.
Kelvin inverse.
Oh.
So temperature, this is for mass, and this is for energy. All right. Are we all seeing that?
Yes, sir.
Yes, sir.
All right.
Yes,
No,
sir.
we can go to activity, right? No, this is taken from an international past paper. Don't worry about it. It's very easy, right? All right. So we have a peanut here, right? We have a peanut here, and it's burning. Now we want to find out the the way that we can transfer or find the temperature of this particular peanut is to put it close to a body of water, because we can easily find the temperature of water. We don't want to break we don't want to break this thermometer because of the heat, right, applied, right? So what can they find out about the peanut by doing this experiment? We can find the specific heat capacity of this peanut by doing the experiment, because we'll see how much heat this peanut is giving off. It's not the ideal way, right? But it's just a particular experiment that we are playing around with. All right. So don't stress too much about that, right? Um, we move now to the actual questions that we want to get. So the temperature of the water rose from degrees Celsius to 70 degrees Celsius, right? So if there were 20 grams of water in the tube, right? We, and the specific capacity of water is 4,200 joules per kilogram per degree Celsius, right? Remember, we can interchange these two. You might see some questions with Kelvin. I wanted to expose you to these, to degree Celsius and to degree Kelvin, because I don't want to tell you just degree Celsius and then you go into the exam and then you see degree Kelvin and say, what did sir tell us? Right? Why sir tell us foolishness? I want to expose it to both of them. So this can be either Kelvin or degree Celsius. All right? This particular guy right here can represent Kelvin or degree Celsius. I said that as we started. All right. So are we all clear so far?
Yes, sir.
All right. So we can move to the question then. If you have any questions, please feel free to interrupt me as usual. Right. So the specific capacity of water. So we need to calculate the amount of energy supplied to the water from this peanut right here. We'll do this question up here. Right. So our formula for specific heat capacity.
Sir, go convert, sir.
Go again. I I heard a question.
Are you going to convert?
No, we're not going to convert, right? We're
Because
not
I saw
converting.
grams there, sir.
Oh, grams? Oh, for grams. Yes, definitely. I
Grams,
thought you meant for the degree Celsius. So we're definitely, thank you so much for picking that out, right? Good eye. So we're going to convert grams to kilograms, but we need to find out first I need to highlight the formula for finding the specific heat capacity, right? And from that formula, we want to calculate the amount of energy, the heat energy supplied. All right. So
Would
it
it
would
be
be
50, sir?
Stan,
The heat energy, sir. Would it be 50?
50. Let's work to it. Yeah, let's work to it. All right. Let's work to it. Right. So specific heat capacity, C is equal to EH over mass times change in temperature. So let's just put that over here. So specific heat capacity, the small c, right, is equal to EH over mass times change in temperature, right? A much easier way to remember this. All right, so we'll talk about that in a few seconds. Forget I just said that. How do we find now the heat energy supply to the water? That's what we want to calculate. Calculate the heat energy supply to the water. How do we go about doing that? We want this guy right here, right? So how would you get this
Yes,
on
sir.
one side?
I think so, you know.
All right, so you can go ahead, Tyrese.
Uh, when you eat energy, right?
Yeah.
But right there. That was 1.5 by X.
So heat energy equal.
C times mass.
All right,
Mass
so mass times C
times C, yeah. No,
times
no
what?
mass. No mass. Mass, the triangle T.
And the delta T, right? Delta T. So this is a much easier way to remember the formula, right? This seems a little confusing, right? But this is a much easier way. I recommend you in when you're trying to remember this formula, remember it in this way: EH equal MC delta T, right? Much easier way. All right, so we have our mass, right? And we have our specific capacity, which would be C. And we also have our change in temperature. So let's fill them out. What is our mass first?
Mass is 4,000.
The mass, right?
Oh. So
a
yes, sir.
joule,
So
Tyrese.
yes.
Right?
Oh, oh,
Sir,
oh, oh.
0.052
Yeah, so
kilo.
we convert grams to kilograms and we basically divide that by how much?
10.
Uh,
Grams to kilograms, right? 1,000, right?
yes, sir.
Yeah, 1,000. Remember that 1 kilogram is equal to 1,000 grams. And we have 20 grams here and X here. Now what do we do next? What's our next step down here?
Convert.
No, we cross multiply.
Oh,
Bro.
Yeah, we cross multiply and we have now X times what?
1,000.
X
Hold on.
times 1,000. So 1,000 X, right? And this is equal to 20 times what?
1 kilogram.
Right, so we
Okay.
have 20 here So what's the value of X now? X,
1000, sir.
we want to get X on one side, so what do we do next?
Carry
Carry
over,
over.
carry over 1000.
Yeah, so how do we do that?
Scale over it, sir.
Multiply or divide,
Divide.
right?
Or
So
you want, or divided by 1000.
yeah, so we divide both sides by 1,000. Divide this side also by 1,000.
And
These
cancel.
2,000s cancel, and we are left with X equal 20 over 1,000, which is just put it. You can put it in a calculator, right?
It's more deep than it.
All right, right.
500. 500, sir.
No, 20
Five-
divided by 1,000, not 1,000 divided by 20.
Oh. So it's, yeah. 0.02.
Right. So 0.02. I see a message in the chat. Right. I saw it, Mr. Moss. Right. I saw the 0.02. I just want to ensure that everyone was up to speed. Right. So please let me know if you're not understanding. Please stop me, interrupt me, please. Right. So we have 0.02, right, as our mass. And what is our specific heat capacity again?
C, which is
From the question for water. Look at B again. What is our specific capacity in B?
4,200.
Right, so we have 4,200. And what is our change in temperature now? That's what we're going to
20,
calculate.
20, sir.
70.
No,
At 70 Celsius.
From
no,
20 to
it
70.
goes,
30. No,
it
no.
goes from 20 to 70. So that would be 70. 70 minus what?
20.
Right, so what do we get
50.
here?
50, sir.
Right,
Never
so
take come out
50
of chat, man.
degrees Celsius, right? See the message in the chat. Yes, you're correct again, Mr. Moss, right?
So,
Times 50. So what's our find out the amount of heat energy required to raise 20 to 70? Right? How much do we get here? How much do we get in our calculator? Let me check as well, just to make sure. Right.
sir, you're going to get back 4,000.
You get back 4,200.
Yes, sir.
All right. Let me add this person. Everyone gets 4,200.
Yes, sir. 4,200.
All right.
4,200.
Okay, that's good. Are we all up to speed? I know Mr. Moss, right, is okay. Mr. Moss got it as well.
My God.
Are we all understanding so far?
Yes,
Yes,
sir.
sir. Comprehended.
All right, now let's try the last question. This is a past paper question, right? So we have to do some application parts to it. So the amount of energy stored in a peanut is much greater than this, right? So not all of the heat energy from the peanut goes to the water. Why? Why is that so? I'm sorry, Miss Gray. I'll have to mute the mic. Sounds like you're in front of the fan. Right? All right. So why not all of the energy is going towards the water? Why is that so? Look back on the experiment, right? Look here. What's happening? We have heat energy. Is all of it going to the water?
No, sir.
Why?
No, sir. Macaroni peanuts, sir.
Hmm?
So much.
What?
Because the heat no concentrate for the tube.
Right. So some of it is lost to the environment, right?
Oh, yes, sir.
Yeah. So we have heat lost to the environment, and not all of the peanut could be burnt as well, right?
Yes,
So
sir.
yeah. So it just could be a small portion. Some of it might go up in smoke, right? And all these other factors. So preparing for your CSEC exam, right? We'll do a lot more past paper questions, right? Going up closer to your CSEC exams. I hope to, for the last couple of weeks, we just go intensely in CSEC. We won't be able to, the truth is, guys, we won't be able to finish the entire syllabus. But what we want to get out of the way is the labs. Once we get the labs out of the way, it's going to be much easier, right? It's going to be
Yes,
much
sir.
easier. And we are actually ahead. My sister is also doing physics at another school. I used to go to that school, and they only do like 3 or 4 labs, right?
Next.
And
None of them, but we have next.
they had grade 10, right? They had grade 10. So she was in grade 10. You did not get to have physics in grade 10, and you have 8 labs going on right now, right? And she only has 3. So um we see that it's difficult, right? It's stressing, I know, right? But trust me, just trust me. I know some of us. All right, so Mr. DeMarc has another class, right, in 2 minutes. All right, so we can close. So next class, we will try and finish up this particular plan, and then we talk more about labs, right? I specifically made this plan very short, specific capacity, very short, so that we can accomplish more lab content next class. All right, so all the best, guys.
All right, sir.
Yeah.
I'll see you next.
I don't know.